Okay, so today we're taking the next step. Yesterday we talked about calipers. Today we're going to take the next step and talk about micrometers. I don't have a good picture of her in the classroom. I'd have some I could hold up for you, but I don't have a good picture. Micrometer is basically, it looks like kind of like a C-clamp, and you screw the end of it, and it twists in and out, and it closes down like a C-clamp. Micrometer, the part that spins, there's actually two parts. There's the barrel that stays steady. Oh, come on now. You got to give me something to ink here. Actually, it'll let me ink. That's what matters. So there's the barrel here that stays steady. Then the thimble is the part that turns. And every one full revolution of that thimble is actually 1/40th. Just gotta be careful here. Yeah, 1/40th of an inch. So you have to turn that 40 times to advance 1 inch. Because of that, most micrometers only have 1 inch of travel. Because if you have one that's like 0 to 6 inches, you got to turn the heck out of that to get it to advance all the way up. So most micrometers only measure between 0 and 1 inch in size. If you need to measure something larger than that, you have to, they make special micrometers. They're called a 1 to 2 inch micrometer, which the smallest it goes is 1 inch, and then it opens up to 2 inches. And then 2 to 3 inch micrometers, same thing. Smallest it goes is 2 inches. So when the jaw is completely as closed as far as you can get it, there's still a 2 inch gap there, and it opens up to 3 inches as you twist it. So we start out reading the barrel is our main scale, just like the body of the caliper. And then the thimble is our secondary scale, like the dial of our caliper. Let me see if I can get this to... allow me to draw. Doesn't look like it's going to let me do it. Oh, that's okay. We can make it work without. So anyway, so on our main scale here, on the body, the barrel of our micrometer here, this is an inch micrometer, and there's two ways to tell. This is labeled in ones, and then the thimble goes from 0 to 20, and then 25 is back to 0 again. Can't really see that on there right now just because the side of the thimble that's showing to us. But we can see this is numbered in ones going up through there. So this is an inch, a standard micrometer. What is marked on here is tenths of an inch. We said it only goes from 0 to 1 inch. So they can't be whole inches, so they're tenths of an inch. So that's 0.1 inch, 0.2 inches, and on up the line. And it has these quarter marks. So this is 0.2 and then another 25 thousandths. So 0.225. 0.225 is what that's reading. That's really going to be annoying if my ink keeps disappearing on me on everything. Let's do this. Way around everything, right? A little bit more. There. That'll work. So that is, again, 0.225. And then on the thimble here, this is where we read the thimble. We read the barrel where the edge of the thimble sat there. We read the thimble where it lines up with the axis of the barrel here. It's the 15 that lines up. Well, that is 15 thousandths of an inch. That's 0.240 inches. So here we've got another micrometer, still standard. On the barrel here, this is 0.4 inches. Then we see the edge of this line, so we need to know, did we make it to that quarter mark, that 25 thousandths? Just like we looked at the dial to see if we had just passed 0 or we're almost to 0 on the caliper, we do a similar thing on the micrometer. We look at the thimble, and what's lined up with the axis here is actually the 0. It's exactly on 0. So that's telling us that that is actually exactly at 0.425 inches. So for this one here, I'm trying to figure out, are we to that 0.8 yet? Well, this is 0.7, 0.725, 0.750, 0.775. Well, once again, we are exactly on 0, which means we have just exactly hit that line. So that's exactly 0.800 inches. For this one, 0.9, 25, 50, 75. So 0.975. And then on the thimble, it is the 5 that lines up with the axis. That's 5 thousandths, 0.005. That's 0.980 inches is what that gives us. Next, something more. Let me check my settings here quick. There we go. So this one here, again, that 6 is lurking there. I need to see if we've made it to the 6 yet. We look at the thimble, and we were 20, 21, 22, 23, 24. We're not quite back to 0 yet. So that means we are not quite to the 6 yet. So this is 0.5, 25, 50, 75. So 0.575. And then on the thimble here, this is actually 24. And again, that's thousandths, so that's 0.024. We add that up to get 0.599 inches. I'm going to have you read this one in your notes quick. We'll go over it in a few seconds. So we have 0.6. Are we to that first quarter? Are we at 0.625? Well, we've just passed 0. We're actually at 1 right here. So yes, we have passed the 0.625. And on the thimble, it is 0.001, or just the 1 that's lined up. So that gives us 0.626 inches is that reading. So here we have another standard one, inch one. So it's 0.4, 0.425. And then over here, this is at 9, 0.009. So 0.434 inches is what we get out of that. Let's skip ahead a few here to this one. This is a depth micrometer, sometimes referred to as an inside micrometer. Similar to the regular standard micrometer, it has limited travel. The inside micrometer is actually limited to only a 1/2 inch of travel. So this here won't go all the way out to an inch. It'll actually only go up to the 5/10 or 1/2 inch. Thimble works exactly the same way. Then you can see we got this piece out here. That is an extension. This says 3 to 4 inches. So that means that is actually a 3-inch long extension. Whatever measurement we're reading here starts at 3 full inches. Then we read the barrel that is 0.2, and it is past the quarter mark, so it's 0.225. And then on the thimble, it's the 20 that lines up, so it's another 20 thousandths. So 542.3, so 3.245 inches is that reading. Now I want you to look very closely at that one and then compare it to this one. There's a very subtle difference between them. This is the first one. This is the new one. The difference is this little piece right in here. Notice when I flip back, that piece isn't there here. This has that extra piece in it. That is a 1/2 inch extension. So this one's not starting at 3 inches, it's starting at 3.5 inches, 3.5 inches. Then we read the barrel, that is 0.325. And the thimble, what's lining up there is 12, so that's 12 thousandths. 7 to 8, 3.827 inches is that reading. Here's the 2 to 3 extension here, so we're starting out at 2 full inches. The barrel, this is 0.32550, so 0.350. On the thimble, that looks like the 24, so that's 0.024, 24 thousandths. 2.374 is what that adds up to. I'm going to have you try this one on your own, and we'll go over it in just a minute. This one has the 3 to 4 inch extension on it, so we're starting out at 3 full inches, but it also has the half-inch extension, so we're actually starting out at 3.5 inches there. On the barrel, that's 0.125. And on the thimble, it is the 10 that lines up, so it's 10,000, so 0.010. 3.635 inches is that measurement. We'll leave that one for a minute. We'll come back to it. So this one here, this is now metric. It's millimeters. There's two ways you can tell. First, the main scale here on the barrel is marked out in 5s, not 1s anymore. And you can see there's much more markings in between. The other way we can tell is the thimble goes from 0 to 45, and then 50 is back to 0 again. So numbered a lot higher on the thimble. You'll notice here on the barrel, this would be 16, 17, 18, 19, and then 20. There are these other marks here. Those are half marks. So this would be 15, 15 and a half, 16, 16 and a half, 17, 17 and a half, 18, 18 and a half, 19, counting up like that. So again, we read the barrel at the edge of the thimble. That's 20. We've made it past 20 and a half. Have we made it past 21? Well, yeah, here's 0. We have just passed 0. So it is actually 21 full millimeters, that is. And then on the barrel, it's the 5 that lines up. Now that is 5 hundredths, so 0.05. That's 21.05 millimeters is the reading we're getting out of that. So for this one here, 15, 16, 17, 18 and a half. We are past that half mark. We can clearly see space on the other side of it. So 18.50. And then on the thimble, it's the 45 that lines up, so that's 0.45, giving us 18.95 millimeters is that reading. So this one here, 5, 6, 7, 8 and a half. We're clearly past the half again. But then we look at the thimble and we realize that's a 0. So either we're exactly on a half or we're actually at the next line. Well, there's no way we're exactly on a half. We're definitely past that half line. So we're actually exactly on the next line. So it's not 8.5 plus something. It's exactly 9.00 millimeters. I'll give you a moment to read this one in your notes, and we'll go over it in just a few seconds. So, 10, 11, 12, 13. Have we clearly passed the 14? Well, yes, we've just passed 0. So we have definitely passed the 14 millimeters. And then what's lined up here is 3. That's hundredths, that's 0.03. So that reading is 14.03 millimeters. I've read this one in your notes. So this is back to being an inch micrometer again. So these are tenths. This is 0.1, 0.2, 0.3, and 25, so 0.325. Then on the thimble, this is a 13, so that's 13 thousandths. That's 0.338 inches. We'll try this one. We'll go over it in a few seconds. We have the 4 to 5 inch extension. That means we're starting out with a full 4 inches. We also have the half-inch extension, which means we're actually starting out at 4.5 full inches. On the barrel, this is 0.4, 25, 50, 75, so 0.475. And on the thimble, that's actually the 24 that lines up, so it's another 24 thousandths. 4.999 inches that adds up to. Finally, I'll have you do this one in your notes. We'll go over it in just a couple of seconds. This one's back to metric. We can tell because it's numbered in fives. So that's 15, 16, 17, 17 and a half. And then on the barrel, it's the thimble, it's the 35 that lines up with the axis of the barrel. That's 17.85 millimeters. So just like we found with our calipers, the real challenge here is making sure we get that decimal point in the right spot. When we're dealing with inches, there are no decimal places. With an inch micrometer, we're starting out with tenths of an inch in most cases, unless we have that extension or an alternative micrometer. When we deal with the metric, there's actually 2 decimal places in front of that decimal point. So at least up to 2. We could have 30, 40, whatever, millimeters as a reading. So make sure you keep those decimal points in mind. Let's look at some simulators here for our micrometers. This is not a simulator, this is actually a quiz. This is what I want. Let's see what this one does. So first we need to identify if this is an inch or a millimeter. And you can tell since there's a 45 here, you know that this is a millimeter because a inch one only goes up to 20, and at 25 it is back to 0. The millimeter goes up to 45, and then at 50 it's back to 0. And of course, we can spin here to twist it. Also, you might notice this is, by the way, down here. That's the appearance of the micrometer. That's kind of that C-clamp type shape. And it actually says 0.01 millimeters or 0 to 25 millimeters on that head. So I moved my thimble here to get a measurement. So let's say our object is between those jaws there, and it fits snug. What do we have here? Well, this is 10, 11, so it's 11 whole millimeters. And now you can see here, we're not exactly on one of the lines here on the thimble. We're between 22 and 23. So we have to ask ourselves, is this a vernier micrometer or a regular micrometer? Now, a vernier micrometer would actually have an additional scale up here above the numbers on the not showing my arrow very well there. On the numbers above that main scale on that barrel. There are no other numbers here, so this is not a vernier. So if it's not vernier, we go to the closest one. The line there, that axis, is closer to the 23 than it is to the 22. So this would be 11.23. Now we got 11.22 down here. That's because this is programmed for a vernier, and the vernier function is shut off right now. Here. So here, this is 15, 16, 17. Have we made it past 17 and a half? Well, yes, we've just passed 0, so we are past the 17 and a half. And this is 5, 6, 7, 8. We're between the 7 and the 8. Now, we're really close to halfway in between. But I think we're slightly closer to the 8 than the 7. So that would be another 8 added onto it. So it would be 17.58 millimeters would be that measurement. Again, this is saying 17.57. That's actually 17.576 is what that's saying. So it really is closer to 17.58 would be the way we'd want to read that. So because this is not vernier, it's a regular metric micrometer, we go to whichever one it's closer to. I mentioned the idea of a vernier. This is vernier, but that's not the one I want. Of course, I picked the wrong thing and shut down what I was using. I'll get right back to it here. There we go. All my stuff disappeared on me, too. I'm going to explain why it wasn't letting me edit. There we go. Okay. So, let's see. Simulator, auto available, simulator. Let's use this one. Let's see what this one is. So this one is the vernier version. So you can see we've got this extra scale up here above the axis on our barrel. So here, now this pink line is just telling us what lines up. Let me just set this to something readable here. Like there. So this still, the beginning part reads exactly the same as any of the others. This is 15 millimeters, that's 16 and a half. So we're at 16.5. And then we still read the thimble at this main axis here of the barrel. That is between 18 and 19. Now it's closer to the 19, but because there's a vernier scale here, we will always go to the smaller one. We'll use the 18. So that makes this 16.68. Because what the vernier scale does, we look up here, we see which one of these lines up. And we see very clearly there's only the one that's highlighted in pink lines up. That's telling me this really isn't, it's between 18 and 19. It's actually 19.8. So that's why it is, or sorry, 18.8, I should say. So it's 16.688. That vernier scale gives us an extra digit of precision on our measurement. So here, this is 1617. It's between the 3 and the 4. Well, it's closer to the 3 anyway, but we would always round down. So that is 17.03. And then the one that lines up here is the 1. So 17.31, which is what it says down here. Millimeters is our measurement. So that when you have that vernier scale, you will always round down if it is between items on the thimble. You will round down, and then the vernier scale puts that next digit on the end of the number. Takes us to the 1,000th of a millimeter instead of just 100th. This is the vernier. I want to save that one for a second. We open this one up. We can tell this is inches because it goes from 0 to 20, and then 25 is back to 0. Also, this is numbered in ones here. So if I look at this measurement right here, just a touch, this is 0.7, 25, 25, 50, 75. So it's 0.775. And on the thimble, it's between 11 and 12. Now, because that's the main axis here, lines up with between the 11 and 12. When there's no vernier scale, so we go to whichever one it's closest to. It's closer to the 12, so I'll take the 12. So this is 0.775 plus 12, so 0.787 would be this measurement. So here, this is 0.475, because we were just past 0. This is between 1 and 2. It's actually closer to 1, so I'm going to take the 1. So that's 0.476 is that reading. Well, let's take a look at what happens if we add the vernier scale to that. So here you can see, once again, above the main axis on our barrel, we have these additional numbers. We read the rest of it just like anything else. So this is 0.8, 25, 50. So that's 0.82 or 850. And that main axis here lines up. It is between the 11 and 12. Now, even though it is closer to the 12, there's a vernier scale here, so we always go down to the 11. So that's 0.861. You can see that's the first 3 digits of our measurement down here. Then the vernier scale gives us the next digit. It tells us how close are we to the 12. Well, and again, this applet lights up the one that lines up, which makes kind of cheating, but it's the 9 that's lined up there, which means we're 9/10 of the way to the next number. So we were really close to getting to the 12, but still it's 11 or 11.9 if you want to include the vernier digit. So this measurement is 0.8619 is what that's measuring. So with the vernier scale on our micrometer, we not only can go to the 1,000th of an inch, we can actually push it and go to the 10,000th of an inch. So if I want to read this measurement here, this is 0.325. We're not to the next marking because we're not quite back to 0, so it's just 0.325. The axis here is between 18 and 19. Slightly closer to the 19, but it doesn't matter. There's a vernier scale, so we go down to the lower number. So we're using the 18. So 325 plus 18 is 343. And then up here is the 6 that lines up. So it's 0.3436. Oh, the good news. The deal I make with my students is this. We're going to take a quiz on calipers and micrometers. Taking it tomorrow. If, as a group, you do well on that quiz, I think there's 12 questions on it, or 6 questions, 2 points each. If you average as a group 9 out of 12 or better, we go on with life and you will never see a vernier scale on a quiz. If we do poorer than 9 out of 12 on that quiz tomorrow, we're going to take another day and come back and look at these again, redo the calipers and micrometers and the vernier scales and everything. And if we have to redo it and you have to take another quiz, there will be vernier scales on that second quiz if we have to get to it. So just so you're aware, there is a little bit of an incentive to do well on this quiz coming up. And I will get that quiz posted later today so it's out there for you. With that, there is homework out of the book, actually. The book does a pretty decent job of the basic inch and millimeter micrometers. Page 183, it is exercise 4.4a, 1 through 20. You just want to read all of those. And page 186, exercise 4.4b, again, 1 through 20. Read those micrometers, inch and metric, and make sure you remember where the decimal point goes and keep track of where the decimal point goes when you switch from one to the other. With that, that is all we have for today. So I'll let you guys have our last 19 minutes or so here to work on homework. Otherwise,